In section 1.5, we start to talk about the order of operations. And the order of operations, if we have an expression like this, you can see it says 5 plus 8 times 7. If we look at this expression, and let's say we take the, depending on which operation we take into account first, we're going to get different numbers. If I do 5 plus 8 first, and then I say times 7, well, this would be 13 times 7, which is 91. If I was to do the multiplication first, 5 plus 8 times 7, if I did the multiplication first, then I would get 5 plus 56, which is 61. You can see we get two different numbers depending on if the only difference between these is on this one I did the addition first, on this one I did the multiplication first. So the order of operations, this gives us guidelines as far as which operations we should do first. You know, because we want, if this is written down, we want there to be one clear winner. Which one of these actually should be explained, or should be the answer. So to kind of help you remember the order of operations, we often use this PEMDAS, P-E-M-D-A-S, and each of these letters stands for a part, something that you see in one of these expressions. So P stands for parentheses. And parentheses in and of themselves, they're not actually an operation. What this does, the P tells us that any operations that are on the inside of the parentheses are elevated in priority. They're going to come first. So you can see how I wrote this out, the 5 plus 8 in parentheses times 7. Because this addition is on the inside of the parentheses, this was my way of saying we do this one first. Over here, I have the multiplication inside the parentheses and not the addition. And that's my way of saying that I wanted to do the multiplication first. So that's what the P of PEMDAS stands for. E stands for exponents. In the absence of parentheses, well, we would look through there and we'd figure out if there's any exponents, and that would be the next operation that would take place. Now the M and the D actually come together. The M stands for multiplication and the D stands for division. I say they come together because neither of those is actually higher than the other, but we had to write, it's just as valid to say PEMDAS as it is PEMDAS. If there is a tie here, if there's both division and multiplication in a problem, in general, the tiebreaker when you're talking about the order of operations is just do whatever one is on the farthest left. So if we had 2 times 3 divided by 2, I would want to do this multiplication before I did that division, because this one is to the left, even though they're tied in the order here. Now, as opposed to if I had 2 divided by 2 times 4, here's division, here's multiplication, this one's farther to the left, that would come first. So this would give me 6 divided by 2, which is 3. This one here, 2 divided by 2 is 1. 1 times 1, or 1 times 4, which is 4. I'll do some examples of these, but I'm just kind of explaining what these mean. So multiplication and division are tied. Addition and subtraction are the last two, and again, I'm going to circle those because these are also tied. So if we had both addition and subtraction in a problem, 1 plus 2 minus, let's do 3 plus 2 minus 1, then these are tied in the order of operations. I would do whichever one is on the left. So in this case, addition is the one that's on the left, so that's what would come first. 5 minus 1, which is 4. Versus if I had 3 minus 2 plus 1, then subtraction comes first, and so because it's on the left. So 3 minus 2 is 1, and 1 plus 1 is 2. All right, so let's just do some examples here. Right off the bat, well, okay, this is the one I did up here. The question was, do I want to do addition or multiplication first? Well, addition comes after multiplication. You can see actually multiplication is this one right here. It comes before addition, so this was actually the incorrect way of doing it. It should have been the second way I did that. So this is 5 plus 56, because 8 times 7 is 56, and then 5 plus 56 is 61. Now, assuming your calculator is a scientific calculator, it should actually be able to do these deal the order of operations just fine. You can see it ends up spitting out 61 here. If I was to type this in individually like this, you can see it gives me the wrong answer. This is the answer I had initially, the 91. So this is one of those cases where it's good to know how to trust your calculator. If I'm typing that whole thing in, it actually does the order of operations. You might actually do this on your calculator and verify that it does show 61. If it shows 91 as the answer when you did 5 plus 8 times 7, then that calculator doesn't follow the order of operations, and you would want to be very careful about using it. You might look into getting a different calculator. All right. On this example, we have subtraction and multiplication. Normally multiplication would come first, but this subtraction is on the inside of parentheses, so it comes first. It's the higher priority. 26 minus 14 is 8. And this may be a little frustrating to you. I'm switching back and forth. I'm using a couple of different symbols for these operations. I'm using the asterisk for multiplication because that's what it shows up on the keyboard as. Normally when we're doing math algebra, we use a dot to represent multiplication, and that's what I'm doing here. So that's what I'm going to do on when I'm looking through all of this. This will be 56. And again, I should be able to type this into my calculator. Let's test that. Parentheses, I'm just on my keyboard typing in the parentheses as normal. And then times 7, and you can see it gives us 84. That's not... It would help if I could actually do subtraction. 26 minus 14 is not 8. Why didn't you guys tell me? Oh, wait. Sorry, bad joke. Alright, so 26 minus 14. I did make a mistake there. Actually, let me leave that there. Making mistakes is not necessarily a bad thing. What is a bad thing is not catching those mistakes. So that's why, when I'm doing these, you'll often see me doing them multiple times. It's not necessarily just to reiterate things for you, but also it's just as much to check my own work. So we're starting out 26 minus 14 times 7. The 26 minus 14 becomes a 12, and we get 12 times 7. I also want you to get in the habit of writing things like I'm writing them here. You can see 26 minus 14 times 7. I just wrote that first line. Then when I made a change, what I'm doing is I'm replacing that 26 minus 14, that stuff right there, I'm replacing with the 12 and just rewriting this expression. This is a good way of kind of keeping track of where you are when you're doing your work. Normally, if you're trying to show your work, this is a very clear way of being able to see what's happening to things. So it lends itself towards the communicating in math. If you're going to be submitting any scratch work to me or anything throughout this course, this is how I want to see your scratch work. Show the original expression, make your change, and then write the original expression again. Then make your change and write the original expression. This is to kind of show, to reiterate the process, the idea that this number here, whatever this is the exact same thing as this number here, and that's also the exact same thing as this number. They're all equal to each other. What I don't want to see, and what I probably won't even try to grade if you submit test work, scratch work to me like this, if you say 26 minus 14 equals 12 times 7 equals 84. Well, what you've said here, whenever you have an equal sign, whatever's on the left should be equal to whatever's on the right. So what you said is 26 minus 14 is equal to 12 times 7. And that's not true. You did say 12 times 7 equals 84, and that's fine. But ultimately, whatever you started with here, this expression should be equal to that expression, because every single time we have an equal sign, they should be the exact same thing. You should not be changing what you're writing midway through. This is kind of the equivalent. This is what I would call a run-on sentence. Didn't expect to be getting a grammar lesson, did you? So a run-on sentence happens when you change the subject of a sentence midway through. So let me think of the dog ran to the owner, which went to the store that sold, well, actually that could be looked at as an adjective. So the dog went to the owner, which went to the store. This would be an example of a run-on sentence because you start out talking about the dog ran to its owner. But then midway through the sentence it starts to talk about the owner went to the store. So that's just it can become a very confusing thing to do when you're trying to read through in sentences, and it's just like in math, it can become very confusing. And trust me, this stuff can be difficult enough without making it more confusing. So essentially what I'm asking you to do is to keep everything, when you're writing this out, keeping it to the exact same, the original expression. Alright, so let's do this one. 4 divided by 2 times 3. We have two operations, division and multiplication. Looks like the division and multiplication are tied, but the division is on the left, so that's the first one that's going to happen, this 4 divided by 2. 4 divided by 2 is 2. And then I'll just write times 3, because that's what was left here. So 2 times 3 is 6. So that would be my final answer.